Okay, so now let's talk about the cellular structure of bone. You can think of bone as being mostly made up of the bone matrix and then the cells that actually help to form this bony matrix. Now, the majority of bone is made up of the bone matrix, which consists of two principal building blocks. The first of which is called osteoid, and this forms the organic portion of the matrix. And then you have something called hydroxyapatite, which forms the inorganic portion of the bone matrix. So first let's talk about the organic portion of the bone matrix. The organic portion of the bone matrix is made up of, like I said, osteoid, which consists of a soft but highly ordered structure of proteins and then collagen, specifically type 1 collagen. So together, the orientation of these highly organized collagen fibers along with the proteins helps to give bone its tensile strength. So what does tensile strength really mean? If you think about a really hard piece of rubber, like a rubber eraser, for example, I kind of think of tensile strength as being similar to the way that piece of rubber gives ever so slightly if you were to push on it, but it still holds its shape. And so that's what you can think of as bone's tensile strength. Now for the inorganic portion of bone. The inorganic portion of bone is made up of a hydroxyapatite. And I'll draw its chemical formula here. It is calcium along with phosphate and water. So basically all hydroxyapatite is calcium phosphate crystals. And these calcium phosphate crystals are the mineral portion of bone that gives bone its rigid strength and density. So now you have a better understanding of the osteoid or organic portion of the bone matrix and hydroxyapatite, which make up the inorganic portion of the bone matrix. So now let's talk about the cells that are actually responsible for making up this bony matrix. There are 4 different types of cells to be familiar with in bone, and the first group are the osteoprogenitor cells. Next, we have what are called osteoblasts. Then there are the osteocytes. And finally, we have the osteoclasts. And so you can see they all share the same root, osteo, meaning bone. So let's make a little bit more room here and talk about each of these cells one by one and what they do. So first up, we have the osteoprogenitor cells. These cells are basically just the precursor to osteoblasts. So basically, they're just an immature version of osteoblasts, and they differentiate into osteoblasts under the influence of various growth factors. So that brings us up to osteoblasts. Now, osteoblasts are the cells that are responsible for synthesizing both collagen and proteins. Specifically, a couple of proteins called osteocalcin and osteopontin. And together, these make up osteoid. Osteoblasts are also responsible for producing alkaline phosphatase, which is the enzyme that is responsible for forming hydroxyapatite, or the mineral portion of bone. Once osteoblasts have synthesized enough collagen and proteins and alkaline phosphatase to form the organic and inorganic portion of the bony matrix around them, and they're finally surrounded by all of this, they mature into the osteocyte. So the mature version of an osteoblast, once it's all done synthesizing the bony matrix, becomes an osteocyte. So that brings us to osteocytes. Now, the spaces that osteocytes occupy are called, within bone, are called lacunae. And the term lacunae really just refers to an empty space within bone. So under a microscope, these spaces look to me like little lakes. And so that's how I remember what lacunae are. They are little lakes or absences empty spaces within bone. And these osteocytes have little arms or branches that reach out to communicate with other osteocytes or osteoblasts, which kind of gives them this star-like appearance. And these little branches are like sensors that pick up new information, send out signals, basically allowing osteocytes to communicate with other cells that help to maintain bone. And then the final cell type is the osteoclasts. Now, osteoclasts are derived from a cell line called monocytes, and they are responsible for bone resorption. So basically, they break bone back down again, and they do this with an enzyme called tartrate-resistant acid phosphatase. So osteoblasts help build up bone with an enzyme alkaline phosphatase, and then osteoclasts help to break that bone back down again with an enzyme tartrate-resistant acid phosphatase. So bone is basically constantly being remodeled, built up by osteoblasts and broken down again by osteoclasts. And an easy way to keep this straight is to think that osteoblasts, the B in blast is for building bone, and then osteoclast, the C in osteoclast is for crashing bone down. So osteoblasts build up bone, osteoclasts break it back down again. Now, as osteoclasts are resorbing bone, they start to form little empty spaces in bone. And wait, what are empty spaces in bone called? They're called lacunae. And so just like osteocytes occupy lacunae, osteoclasts occupy a special kind of lacunae called Howship's lacunae, which are just the little resorption pits formed by osteoclasts as they break down the bone surrounding them.